All right, this is the video for Thursday, the 23rd, 22nd, 23rd of April. So we are wrapping up our school week. Hope you're doing well. Our theme this week has been working with radicals, things that live under those square root and third root or cubic root signs. So I'm going to do one of the questions from last night's homework assignment, yesterday's homework assignment, and hope that it's helpful to you. I'm going to go through this pretty quickly because we've got some new material to cover before I set you free to do today's worksheet. So number 5 on yesterday's assignment said that y equals 1/2 the square root of x minus 2 plus 1. So the x minus 2 lives under the radical sign. And of course, the first thing we want to do is we want to create a table to calculate our values of y, given the values of x that we choose. Now, of course, if you paid attention to yesterday's video, you know that there's easy ways to do this and there are hard ways to do it. And I always choose to do things the easy way. When you're taking the SAT, if you need to do this, you don't want numbers that are hard to deal with. You want to be able to manipulate these numbers so that you can do it pretty quickly. So I want the number underneath the radical sign to be a perfect square, okay? I want it to be 1 or 0 or 4 or 9. I want it to be something like this. So I just have to do a little bit of thinking ahead. It's x minus 2. So I'm going to put my x's here, y here. And so whatever number I choose for my x, I know I'm going to have to subtract 2 from it. And I want that to equal my perfect square. So you know my drill. Here's what I want to do. I want this one to be 2. This one to be 3, okay? Why? Because x minus 2 is going to be 0, or 2 minus 2 is going to be 0. 3 minus 2 is going to be 1. Those are perfect squares. My next perfect square is 4, which would require me to have 6 and then 11, okay? You could choose any numbers. I choose those numbers because it makes my life easy. All right, so now I'm going to calculate a y for each of those. So let's pretend that I've taken my x here and I have y equals 1/2 the square root of 2 minus 2 plus 1. So y equals 1/2 of the square root of 0 plus 1. So y equals 0 plus 1. So y equals 1. All right, that's my first ordered pair. When x equals 2, y equals 1. Easy. All right. So my next one, x equals 3. 1/2 of the square root of 3 minus 2 is 1, so the square root of 1. Okay. 1/2 of 1 plus 1 is 1/2 plus 1, so y equals 1 and 1/2. Okay. Alrighty. Y equals 1/2 of the square root of 6 minus 2 plus 1, 1/2 of the square root of 4 plus 1, 1/2 times 2 plus 1, 1 plus 1, or 2. All right, and my last was 1/2 of the square root of 11 minus 2 plus 1, or 1/2 of square root of 9, 1/2 of 3 plus 1, 1/2 times 3 is 1 and 1/2, 1 and 1/2 plus 1 is 2 and 1/2. Okay, so here are my ordered pairs. I'm going to do this really quickly. Of course, here's my y, here's my x. My x is going to go all the way up to 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Those are not nice equal hashes. Wish they were, but they're not. Try to straighten them up a little bit. Okay, so that's 11. And my y goes all the way up to 2.5, so it doesn't go very far at all. Let's just say that right there. All right, when x equals 2, y equals 1. When x equals 3, y equals 1.5. When x equals 6, y equals 2. So it's 2, 4, 6, 2. X equals 11, y equals 2.5. That's going to be about right there. And, okay, so that's not, there we go. All right, and I get that kind of half bullet looking shape. That's what a radical looks like when it's graphed. Okay, so hopefully that's just a quick review from last night's assignment, and we'll be able to do that in the future. Okay. So today's assignment, we're going to work on simplifying radicals using prime factorization. Now, you can't do prime factorization if you don't know what a prime number is, okay? So a prime number is a number that only has two factors, and that is itself and the number 1, okay? So for example, 2. 2 is the smallest prime number. I'm going to tell you the honest truth, 1 is not a prime number. 1 has never been a prime number. 1 will never be a prime number, but I really can't explain to you why, because every math professor I ever had just said, well, just take it for granted 1 is not a prime number, because it isn't. So, okay, so our first prime number is 2, all right? In other words, if I talk about the factors of 2, I've got literally 2 times 1. And that is so not interesting that I'm never going to write that on a factor chart. If I can factor a number down to 2, then I'm just going to say, all right, that's done. All right, let's say, for example, I have 10. I make a little factor tree. That's where I'm going to show the numbers that factor into it. And I have 2 times 5. Well, 5 is a prime number as well. You can't get anything out of that besides 5 times 1. 2 times 1, so both of those are prime factors. So this is the process called prime factorization. Let's take a number that requires a little bit more of factorization. Let's take a number like 100. Okay, 100 is one way. There are several ways to break this down. It's 10 times 10. Well, what if I had gone with 20 times 5? Well, the truth is that if I keep breaking these numbers down until I get down to prime, no matter which way I go about it, so whether I start off with 10 times 10 or 20 times 5, if I break it down to where I just have my prime factors, it's going to be the same in the end no matter where I start, okay? So your worksheet might not look exactly like your neighbor's, but that's okay. You're going to end up with the same answer in the end. 10 is 5 times 2. 10 is 5 times 2. So we've got 2 5s and 2 2s, all right? So if we wanted to put it back the other way, we could say that 2 squared times 5 squared equals 100, okay? How did I get my 2 squared? Well, I have 2 2s. And where did I get my 5 squared? 2 5s. So that's 2 squared and that's 5 squared. Well, let's think about it. What is 2 squared? It's 4. What's 5 squared? 25 equals 100, okay? So that is prime factorization. Now, if we're doing it to solve radicals, I'm going to do the same problem over again, but I'm going to put the 100 underneath a radical sign now, okay? In other words, I'm going to I want to solve or simplify the square root of 100. Well, the square root of 100 is the square root of 10 times the square root of 10. That's a lesson we learned earlier, okay? So that would make 10 the square root of 2 times the square root of 5, square root of 2 times the square root of 5, okay? So in other words, we have the square root of 2 times the square root of 2 times the square root of 5 times the square root of 5. I can combine these identicals to look a little different, okay? So that the square root of 2 is 2 squared, the square root of 5 is 5 squared, and now I'm multiplying those two with each other. Now I want you to notice something. What is, I'm about to run out of camera space here, aren't I? What is the square root of 2 squared? It's 2. What's the square root of 5 squared? It's 5. Okay? So if I take these simplified numbers down here, 2 times 5 equals 10. Well, okay. Isn't the square root of 110? So notice how we did this. Now, obviously, you should know that the square root of 100 is 10, but what if I gave you a number that was not a perfect square? In other words, what if I said, I always get in trouble here because I just make things up. What if I said the square root of 88? Okay? It's not a perfect square. I can say that it is the square root of 8 times the square root of 11. All right? 11 is a prime number. Now, because I have lots and lots of confidence in you, I know you can figure out the prime numbers. You need to go ahead and memorize them anyway. At least through 100, there's not that many of them. The higher the numbers go, the greater the space is between them. However, I wrote down on your worksheet all the prime numbers that you probably need to know for Algebra 1. Okay? So when I get to 11, 11 is prime. I can't multiply anything times some other number and get 11 other than 11 and 1. So I'm going to leave that guy right there. I'm going to say square root of 2 times the square root of 4. And this guy is the square root of 2 times the square root of 2. All right. Now, here's what I have broken the square root of 88 down into its prime factors. And I'm just going to circle them so you see what I've got. Got to be careful that you don't leave any of your factors out. I have the square root of 2 times the square root of 2 times the square root of 2 times the square root of 11. Okay, if I have doubles, okay, exactly 2, I can put them together. In other words, square root of 2 times the square root of 2 can become the square root of 2 squared times the square root of 2 times the square root of 11. All right? And now the square root of 2 squared, I know what the square root of 2 squared is. It's 2. I'm going to rewrite this as 2 times square root of 2 times the square root of 11. At this point, and I've kind of run out of room, okay, but at this point, I want to combine anything that is a whole number, in other words, anything that's not under a radical sign, and I want to combine anything that's inside a radical sign by multiplication. Okay, so I'm just going to write this over here, that 2, can't see my finger, 2 times the square root of 2 times the square root of 11 is the same thing as 2 times the square root of 22. In other words, the square root of 88, when simplified, is 2 on the square root of 22. That's the simplified version right there. Okay? So there are 5 steps. First of all, you're going to factor all the way down to prime. You're going to identify what are identical pairs. Now, in this particular example, I circled all of the factors because this is our first time to do it. If you'll be really careful and you won't miss any, then really what you would do at this point is you'd start circling just your doubles, right? And then, of course, when you get down here, you want to rewrite. At this stage, you've written all of your factors. At this stage, you've combined any doubles to make them the square root of squares. And then at this stage, you're rewriting them, getting rid of as many radicals as you can. So these are the numbers that we were able to simplify. These are the numbers that we weren't able, and it's going to be a whole number times a radical. Boom. Okay? All right, so you have a worksheet that has instructions, step by step, what I just did. You have me to text or call or FaceTime or whatever. It's not that hard. I know that you can do it. And I look forward to seeing your assignment texted to me soon. So anyhow, tonight at nearly midnight, I received just a heart-rending text from one of my students who said, implied, didn't quite say, but implied that perhaps this watching algebra videos and doing worksheets was boring. Well, I tried to come up with a good comeback for that, and I'm still working on it. So if I can come up with a good comeback, I'll post it next week. In the meantime, do your work. I hope you're keeping up with your other classes, your teachers. Grades do count. Can I just tell you something crazy? I had a parent, like I'm not even kidding, I had a parent text me and say, I heard that grades are not being kept for all of this e-learning. Like it really doesn't matter if you do your work. And if something like that were to be the case, I would post that officially. These grades count. These grades absolutely count. Believe it or not, I'm actually having to report attendance, even though we're not even in the building. I'm having to report attendance to the state. And when you participate, I'm able to count you as present. When you don't participate, I have to count you as absent. I have to tell the state whether or not you were present in school today. Yeah, your grades count. See ya.